Welcome, Math 13 students. We have a presentation here on finding the margin of error in section 7.1. When we estimate a population proportion, we'll take our point estimate p hat, we add and subtract the margin of error to that value to build the confidence interval. So come with me to my other screen and we'll go ahead and run through the process. It's pretty straightforward. We've used a lot of the keystrokes before, so it should go pretty quickly. All right, chapter 7. Here it is, finding the margin of error. So we're going to review the formula for the margin of error for estimating a population proportion. We'll use the inverse norm tool to find critical values, and we'll introduce appropriate examples as we go through this process. So our margin of error, it depends on the sample size and the level of confidence. And we combine that margin of error with the point estimate to produce the confidence interval. So in terms of a formula, my margin of error looks about like that. E equals z alpha over 2. That's the critical value times the square root of p hat q hat all over n, which if you sort of look close is really what you get with the central limit theorem. There's a square root of the sample size somewhere in that denominator. So once I have that margin of error, I can then go ahead and build my confidence interval. The first example. Are you going to vote in the next election? Well, a random sample of 100, 75 of them said, yeah, I'm going to vote. So we're going to find the margin of error when we want to estimate the proportion of the population that is going to go vote. So the task, find the margin of error, clearly spelled out. The data, also really visible, x equals 75 and n equals 100. Now, the critical value, the z alpha over 2 we need in that formula, that's not so readily available. I actually have to go get that myself. And that's really the majority of the process. So we'll set up and ID the values. We'll get the critical value from the inverse normal tool. We'll use the formula, and then I'll say a little bit about rounding. So there's the formula. P hat, x over n, 0.75. Q hat, 1 minus p hat, 0.25. Alpha, 5%, 95% confidence interval. There's my distribution, and I need those critical values right there. I'll go to my inverse normal tool. That will find them for me. Area, mean and standard deviation, and there we go. There's a positive and a negative. I'll just use the positive, and it goes into the formula. Order of operations plays really nice here. I plug it in just as I see it. Hit enter. Now, I'll round this to 2 decimal places, and there we have the margin of error. Now, I will say this, there is no hard and fast rounding rule for the margin of error. I usually like to bring as many decimal places as I'm carrying for p hat. That seems to make a certain amount of sense, but honestly, there is no hard and fast rounding rule. The process is pretty straightforward. You need the formula, really the process where you have to go get the inverse normal tool and use that as the most involved aspect here. But there you go, there's your example. So we took a look at the margin of error, and we used inverse normal to go ahead and find the critical values, and we have a nice example to look at. That's the end of my presentation. I'll stop my sharing, and I'll say goodbye, come back, and watch the videos.